When counting the number of possible outcomes, sometimes order doesn't matter. That's where combinations come in. And we're going to talk about those right now. Welcome to Math Bytes. I'm Allison. And today we're talking about combinations. Let's say you're ordering a pizza and you can choose 3 out of 8 toppings. If you choose onions, olives, and bell pepper, that isn't different than choosing bell pepper, onions, and olives. The order of the toppings doesn't change the outcome. That's where combinations come in. Here's a formula for you. The number of combinations of R objects chosen from N objects, where R is greater than or equal to 0 and less than or equal to N, is equal to N factorial over the quantity N minus R factorial times R factorial. That counts the number of combinations, where order doesn't make a difference. Let's continue with our pizza example to see how this works. You're ordering a pizza and you get to pick 3 toppings from a total of 8 choices. How many combinations are there? Okay, so let's remember that the number of combinations of N things taken R at a time is equal to N factorial over quantity N minus R factorial times R factorial. Now in this case, N, the number of things we're choosing from, is 8. There's 8 possible pizza toppings to choose. And R, the number of things we're choosing, is 3. We get to pick 3 toppings for our pizza. So what we've got then is the number of combinations of 8 things taken 3 at a time. And that's equal to 8 factorial over quantity 8 minus 3 factorial times 3 factorial. That's equal to 8 factorial over 5 factorial times 3 factorial. And on the top, that gives us 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, we have 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. Now, you'll notice that everything from 5 to 1 on the top will cancel with that 5 factorial on the bottom. And that leaves us with 8 times 7 times 6 over 3 times 2 times 1. That's equal to 336 over 6, which is equal to 56. There are 56 possible pizza combinations in this case. Let's do another example. How many 5-card hands can be dealt from a standard 52-card deck? Now these are combinations because what matters is the cards you hold, not the order in which they're dealt to you. So in this case, N, the number of things we're choosing from, is 52. 52 cards total in the deck. And R, the number of things we're choosing, is 5. We're dealing a 5-card hand. So the number of combinations of 52 things, taken 5 at a time, is equal to 52 factorial over the quantity 52 minus 5 factorial times 5 factorial. That leaves me with 52 factorial over 47 factorial times 5 factorial. And that is equal to 52 times 51 times 50 times 49 times 48 times 47 factorial. I don't need to write all those digits out. I can just write out the first few. And you'll notice that the 47 factorial on the top will cancel with the 47 factorial on the bottom. So I am left with 52 times 51 times 50 times 49 times 48 over 5 times 4 times 3 times 2 times 1. And that's equal to 311,875,200 over 120. And that's equal to 2,598,960. That's how many 5-card hands can be dealt from a standard 52-card deck. To make sure you're working with combinations, ask yourself, does order matter? If I change the order of the objects, do I get a different outcome or the same outcome? If order doesn't matter, you're dealing with combinations. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com, and we'll see you next time.